Modern algorithmic trading environments are dense, chaotic, and relentlessly fast. For a systematic trader, the hardest part isn't necessarily finding an edge in this data, it is translating that edge into executable logic. Traditionally, that means manually writing every parameter into MQL4 or MQL5 code. This manual coding pipeline creates a severe bottleneck. A trader's intuition and market observation become trapped behind strict syntax requirements, slowing down the iteration cycle. The Autonomous Trading Engineer, or ATE, is designed to break this bottleneck entirely. Instead of forcing a human to type out explicit parameters, the ATE operates on an observe and create model. A multi-layered agentic AI architecture sits directly over the MT4 or MT5 terminal, replacing the traditional code editor with an intelligent monitoring layer. It manages the entire Expert Advisor lifecycle through 4 distinct phases: observation, generation, testing, and deployment. The ATE removes the human requirement for writing syntax, replacing it with an autonomous system that synthesizes executable logic directly from observed market behavior. To understand how the ATE accomplishes this, we have to look at how the system extracts information without explicit human input. The engine relies on a process called observational learning, operating quietly within the MT4 or MT5 environment. This schematic shows the first of 3 core data integration streams: market data. The AI actively monitors live charts and indicator values emerging here from the terminal. These live charts and numerical indicator outputs provide the immediate environmental context, establishing exactly what the market is doing at any given second. Next, a parallel stream pulls execution data directly from the terminal. By tracking trade execution logs and order history, the AI sees the exact entry and exit behaviors of the trader in response to that market data. Finally, a third stream integrates the system logs, pulling detailed diagnostic data directly from the terminal journal. Traditional algorithm development requires a user to manually flatten their strategy into static numerical parameters. This multi-threaded ingestion captures action in real time. By observing this complete ecosystem of terminal data simultaneously, the ATE captures the exact nuances of a human's trading strategy, details that are almost always lost in manual translation. The next step is processing that raw observational data into structured logic. This flowchart tracks those 3 data streams as they flow into this central node, the observation and synthesis engine. Inside this engine, the system correlates human interactions on the active charts with the back-end terminal journals, crystallizing the disparate data points into a structured, branching logic tree. By correlating specific trade timestamps with the exact price action and indicator states present at those moments, the engine maps the implicit patterns of a trader's actions into explicit, executable parameters. Once the logic tree is structured, it flows into the automated generation phase. Here, the module outputs a compiled Expert Advisor. The AI autonomously writes functional MQL4 or MQL5 code, strictly adhering to the parameters established by the logic tree. Compared to a human quant workflow, this process reduces development time, scales across multiple strategies, and eliminates manual syntax errors. The synthesis engine replaces the variable process of manual interpretation with an objective, code-driven translation of behavioral data. Generating functional code is only the first step. The resulting logic must then be validated against historical data to establish its risk profile. To ensure the strategy is robust, the ATE utilizes an automated backtesting capability. Returning to our diagram, the system routes the newly generated Expert Advisor directly into the platform's built-in strategy tester. Here, it is bombarded by rapid simulated market conditions. This stress testing generates validation data, proving whether the synthesized logic holds up under historical market scenarios. Once the strategy passes validation, turning green on our chart, it advances to the live deployment module, placing the algorithm into an active trading environment. However, the ATE's engineering job continues even after the EA is deployed, initiating iterative improvement. The system actively monitors live trading results alongside manual user corrections. This generates a continuous stream of refinement data, which loops back into the observation engine. This closed-loop feedback mechanism ensures the Expert Advisor is not a static, rigidly coded bot, but a dynamic asset that continuously evolves alongside changing market conditions. Beyond the microarchitecture of the pipeline, the ATE is designed for significant macro-level scaling. The current development focus is validating the functional prototype specifically within the MetaTrader ecosystem. Phase 1 involves onboarding 20 to 50 beta users to stress test the AI across diverse, real-world market conditions. The core benchmark for proving the system's scalability in this phase is achieving 100 successful, fully automated expert advisor generations. From there, Phase 2 initiates the commercialization strategy, with the immediate goal of converting beta participants to establish a baseline of 10 paying customers. With a proven product and initial revenue, the roadmap targets a pre-seed funding round of $500,000 to $2 million to expand the engineering team. This funding unlocks Phase 3, expanding the ATE architecture beyond MetaTrader, as seen in this expanded roadmap diagram. The objective is platform integration, ensuring the system can support diverse trading environments like TradingView, cTrader, and NinjaTrader. Concurrently, the platform will execute a language expansion, developing Python-based trading models. Python integration is required to reach institutional and data science trading segments, which operate outside the limits of MQL script. With the expansion into Python and institutional platforms, the ATE moves beyond script generation toward a system for automated quantitative development across global financial markets.